Today, we're reviewing input and output from basically CS102. What you'll see in this first month is that we'll cover topics from CS102, but in greater depth, and sometimes introduce some new information. So today, we're talking about CIN and COUT, but we're also introducing a new print command called PrintF, which is, in my opinion, an easier way to print formatted output, and we'll make you use it for a couple labs, and then after that it'll be up to you which one you use, although you'll be responsible for using PrintF on exams. And we're also going to go into a little bit of detail today about how to use CIN when you're getting bad data from the user. We kind of touched on that in 102, but in 102 we usually didn't have you do a whole lot of error checking, but in actuality, error checking is a big part of what you do as a programmer. It's a pain in the neck, but you've got to do it. And so a big part of today is showing how you use CIN to do both error checking and to recover from an error when a user makes it. So had you do the reading beforehand, hopefully it was mostly review except for one thing which I want to quickly cover here. So this is a diagram from the textbook showing how output is done using COUT. And you may or may not have covered this in 130. I'll actually ask about it after the fact. So that's the problem with this pen. Thank you. Hold up just a sec. Okay, so you might or might not have covered this in 130, but it's kind of important that you look under the hood of the computer and know how it's actually working when it is outputting something to the screen. So in this case, we have two COUT statements. One is outputting age, and one is outputting the string literal age. And the second COUT statement is outputting the contents of the variable age years. And it would appear to you as though COUT prints directly to the console, but that in fact is not true. What happens is there's an intermediate step where COUT actually copies the string literal and the contents of the variable into something that we call a buffer. So it goes into a holding area. You know, you go into the doctor's office, you're in a waiting area. It's the same thing. Actually, before the characters get flushed to the screen, they're put into a waiting area that in memory that we call the buffer. So what actually happens if we do this little animation is you'll see that first the string literal age is copied into, there we go. You see A, G, and E is getting copied into the buffer, and now the contents of age years gets copied into that buffer. So it's now held in the buffer. Nothing has actually gone to the screen yet. At some point, when the buffer fills up, then C++ will actually copy the contents of the buffer to the screen. So that's the next step here, where it actually copies the buffer to the screen. And you might ask, okay, why this intermediate step? Why hold these characters in memory? And the answer is that it's kind of expensive to write directly to the screen. And if you write to it in bulk, it's more efficient. So writing 4 characters to the screen is costly, and it involves the reservation of resources. It slows down the CPU. So it's not the most efficient operation. So to make it more efficient, the compiler arranges to hold this stuff to be printed in a large buffer, and only when the buffer becomes fairly large does it actually say, okay, we will make go through this reservation process of reserving some resources and asking the CPU to copy these characters to the screen, and it does it all at once. And normally, you don't notice this because the output is coming out so rapidly, because the computer is pretty fast, that you don't notice the fact that it's not writing to the screen immediately after each cout statement. But in fact, this is what is happening, and occasionally that's going to be an annoyance to you. It's going to not, we call it flushing the buffer when it writes to the screen. So we call it flushing the buffer when it writes to the screen. And sometimes you'll need to explicitly try to force it to flush to the buffer. And the best way to do that is when you print out something, use endl for your new line character. Endl always forces the output to the screen from the buffer. It's okay to also use new line, as Dr. Plank says in his notes. So I don't care which you use, okay? Both are fine, and you won't get penalized for using either one in the lab. But endl always flushes the buffer. Okay, whereas \n does not. So if you use \n, it's possible that something that you print using a cout won't immediately appear on the screen, and you may get fooled into thinking that the cout statement has not executed when in fact it has. And it's simply that the output is currently sitting in the buffer and has not yet been flushed to the screen. Okay? So just keep that in mind, that this is the way output really happens. Is it's first copied into a in-memory buffer. You don't have to worry about it. It's something that the compiler arranges to have happen, and then when enough stuff is in the buffer, it goes to the screen. And if you absolutely have to flush the buffer, this is very rare, but just so you know, there is a .flush command for cout. Really, I don't think you should ever have to use this command in this course. It's just a piece of information. Okay, so questions about that. Was this covered in 130? I'm just curious. No, it was not. Okay. Okay, so I'm going to move on. So that happens with input too. Actually, input is read kind of several lines at a time from the screen into a buffer, and then as you request it using cin, it's extracted and given to the program. So again, just like output, input comes through a buffer actually. You don't need to know that as far as your programs are written, but it's helpful to know what goes on beneath or behind the scenes, so to speak. So that's what's going on behind the scenes. Okay, so the big thing that I want to cover with cin today is some of the pitfalls with cin, and also how you use cin in order to recover from errors. So the first thing I want you to do is, actually, if you have your computer here, I want you to write a very short program, and all it's going to do is read 10 integers from the screen. Actually, don't even make it that hard. All I want you to do is write a program that reads integers and prints them out one per line. So write a program, a C++ program, that reads integers from cin and prints them out one per line. Okay, and feel free to go to the textbook and look at it if need be to help you with writing this. This is a very simple program. I'll give you about 5 minutes to write it. If you don't have your computer with you, use paper and pencil. This is just a useful exercise to kind of knock the rust off. Okay, like I said, feel free to collaborate with your neighbor on this. If you don't have C++ loaded on your laptop, I can't really help you with that in class, but the TAs can help you with that. See them during their office hours, and they can get it up. And for just this today, just either work on a piece of paper with a neighbor on it. And if you have a question, raise your hand, and I can come around and try to help. Let's pick this back up. So here's my program that I wrote for reading it. It's pretty simple. You simply iterate until you reach end of file. So this while cin into value idiom is one we taught you in CS102. So if the read succeeds, it returns true, and you enter the loop and it prints out the value. If it fails because you reach end of file, then you drop out of the loop and the program ends. Okay? So this is kind of the idiom we prefer that you use for reading from cin or from a file. Works very well. Okay? And let me just show you that it works. Actually, let me create a second window here so those of you who are copying can keep copying. So we'll put it side by side. So if I run it, enter 10, it prints 10, enter 30, it prints 30, enter 40, it prints 40. Hit Control D, if you remember, that's how you can terminate input on a Mac. On a Windows machine, it varies. I think Control Z often is the right thing, but if I hit Control D, that sends the end of file character and it terminates the program. So Control D on a Mac or on Linux terminates input from standard in. I believe Control Z most commonly is the end of file indicator for Windows. Now here's something that you should learn with Linux, and that is you don't always have to type directly into the console for standard in. It is possible to enter your input into a file and then do what we call redirection, where you tell the program to take its input standard in, instead of taking it from the terminal, to take it from a file. So here's some file that has some data in it, and the more command simply echoes out the contents of a file. So here I have the values 10, 20, 30. And the way that I do redirection is with the less than character. And then the name of the file. So this tells the program that instead of taking standard in, so cin will now read from this file called data rather than from the terminal. So that's very helpful. If you're debugging a program and it's taking it from standard in, and the error doesn't manifest itself until like the 20th piece of data, it can be very tedious to have to make a fix to your program, recompile it, enter 20 pieces of data manually, and then find out whether what your fix, whether it worked or not. It's a lot easier to enter your data into a file and then simply use this redirection operator and have it send the input to your program. Okay? And just like you can redirect standard in from a file, you can redirect standard out to a file. So I could also have redirected this to, say, output. So now it's taking, cin is taking its information from data, and cout is sending its output to a file called output. Okay, so you see now there's no output on the console because cout wrote all of its output to this file called output. Okay, so the less than symbol redirects at the command line, redirects standard in. We call it redirect standard in so that it comes from a file, the name file. And the greater than character redirects standard out so that it goes to a certain file. Okay, so that's also helpful because sometimes you have a lot of output from a program, and by storing it into a file, you can go in and use VI to look at the output, whereas if it all kind of just vomits its way onto your screen, you may miss it, what you need. Okay, so this is called redirection. Okay, so now let's show you a couple common mistakes. The first one is one we really want you to avoid, which is to get into the trap of using EOF. So some of you inevitably think that you can use EOF like this. So you think, okay, this says while, actually, I want to say while not. So while not EOF, so while we have not seen the EOF character, we'll read the next integer and print it out. Okay, this looks pretty correct. In fact, the book used this example. Okay, in I think it was section 9.2 or 9.3. So let's see what this, let's compile it. And let's see what this program produces, okay? So again, I'm going to read in from data, which we know has 10, 20, and 30 in it. Okay.
What's the file extension for data? Is it .dat or .txt?
It should be, it doesn't matter. It should be technically .txt, but for old fogies like me who used to use traditional Unix, there doesn't have to be an extension on a data file. So you'll never see me put an extension on a data file, but by convention is .txt. Okay, I'm certainly not going to bust your chops for not putting a .txt after it. So, okay. So does anyone see something problematic with this output? 2 30s. There's only 1 30 in that data file. Okay, 10, 20, 30, but I have 2 30s in my output. So something is wrong with this program. Here's the problem. EOF is what we call reactive, not proactive. So it does not know that it has reached end of file until it has attempted to read a value and failed. So let's see what happens when it gets to the last line in the file, which is 30. Okay? When it gets there, it comes in, there's still one line left, 30. So it hasn't reached end of file. It reads 30 into value and prints out value. Very good. We have 30 there. Now it comes back to the top and it says, while not EOF. Well, it has not actually seen the EOF character yet. Okay? It's not, C++ isn't omniscient. It's not able to see into the future. It can't see that the next character it's going to read is an EOF character. So it returns false, saying it has not yet reached EOF. It now drops in one more time and attempts this read right here, and it fails because of EOF. So what happens when it fails is it leaves the contents of value unchanged. And when we hit this cout statement, it prints out 30 a second time. Now when we go back up, we have in fact seen the EOF character and we exit, but it's too late. We printed the last line seemingly twice. The moral of the story is please don't use EOF in your program. It's very dangerous for this reason. Okay? The book actually used it without telling you that there was an error problem. So in the book, in section 9.2, nope, what was section? Would be output formatting. Is it stream errors? I believe it was stream errors then. Here it is. This was the wrong program, and it's going to be, it's saying while cin.fail, cin.clear, read cin.number, and I actually ran the program, and in fact, it did print out the last line twice. So don't do it this way. Even though the book does it that way, it's wrong. Okay? The way we want you to do it is to say while cin into value. That's the way to do it. Okay? Now, hopefully you've had a chance to actually either copy this program that I have here, or you have got something working yourself. I want you to try to put some bad data into readers. So 10 works. What happens if we put Fred? Okay, well, let's give it a try. What do we think happens? What do you think will print out? 10. Well, print it, actually. Let's do a more on this. So actually on your output, you can also put in a more. So, whoops. Okay. It printed 10 first, and then after that it printed 0. So it actually ended up putting a 0 into value. But what exactly is going on? And we're in an infinite loop, clearly. Okay, so not only did it fail, but we're in an infinite loop, which you can get out of using Control-C. Okay, you will get into infinite loops sometimes. Control-C will get you out. So what happened? Anyone care to hazard a guess? It certainly failed. Okay, it was expecting an integer. When it read here, tried to read into value, and it failed. Okay, and then something happened. Okay, well, first question to ask, because this is something you're going to have happen a lot where you have to debug a program. Okay, so you have to start asking yourself questions when this happens. So the read failed, right? did the return value, was that true or false seemingly? That is, did it think that it succeeded or failed based on what happened subsequently? Seems like it succeeded. Why? Because it went into that loop. So apparently it returned true as to the success of the read. And apparently what value did it decide to put in there when it couldn't read Fred and convert it to an integer? It put 0 in. Okay? Now, I'm going to change it up for a moment. And I am going to put mad in there. It still went that way. Okay. So, I'd remembered something which is on a Mac. There's a special thing with integers, which is if the word starts with A through F and a couple other special characters, it treats it as hexadecimal or other special things. But even if I started it with an M, it went haywire. Okay, so it went into the loop. It printed out value. It must have come back out, but clearly it never attempted another read, right? Well, at least it never read anything back from standard in. If I do this, let's try it with data. Let's change data and change the second one to mad. Okay, and run it. And now I want to save some of the output, so I'm going to put into output. We're in an infinite loop. Okay, and you can see it still didn't work. We got a lot of lines though. At the bottom you can see there's about 5 or 6 million of them. But again, it clearly read the 10. It couldn't do anything with mad, but also you can see it never did anything with the 30, right? So somehow it just got stuck. So you know how with a copy machine you put in a piece of paper and sometimes it gets jammed or a printer gets jammed, right? So that's what happens when you give Cin a bad value and it can't convert it. It gets jammed. It's like a printer jam, okay? And what you have to do, just like you have to pull a piece of paper out of the printer, you have to pull the bad value out of the input stream and then restart Cin. Okay, so if this was a printer, you would pull the paper out and then you would probably hit a button on the printer to restart it, right? Okay, so there's a way to do both of those things with Cin. So the reset button is cin.clear. So clear clears, no, I won't script on you, clears Cin after reading a bad input value. But does not remove the bad value from the input stream. So it's equivalent to hitting the reset button on the printer, but leaving the bad piece of paper in the printer. So we still have to remove the bad piece of paper. Okay? Now, with the printer jam, you'd remove the piece of paper first, and then you'd hit the reset button, right? With Cin, the operations are reversed. The first thing you do is you do Cin.clear. And then the second thing you do is you remove the bad value. And the way you do that is you create a string variable to hold the bad value. And after clearing, you simply read that bad value into the string. And the reason that works, does anyone know why it should always work to read into a string value? Because anything's a string, okay? Whereas when you have an integer variable, it specifically expects an integer. Or if you have a floating point number, it specifically expects a floating point number. But a string basically is like the garbage can. It takes anything. Okay? Unlike the recycling where you're only supposed to put plastic or bottles in. Whereas the regular trash takes everything. So the string takes everything. So if you're trying to clear cin, first do cin.clear, then remove the bad value from the input string by reading it into a string variable. And then you're good to go again. But do it in that order, okay? So let's come back here and what we're going to want to do now is we're going to want to get rid of values that don't succeed. So we're going to come in here, and now it's a little more complicated. Okay, so first of all, we want to see whether it succeeded. So if cin.good, then it succeeded. And we'll print it out. Okay, so good tells us whether it's in an okay state. So if it succeeded, we're fine. Remember, even if the read failed, we're still in this loop. Okay? So now, else it failed. So we do our little operation of clearing. And I'll be good. I'll put my string variable up here. Okay, and I'll say cout bad input equals, and I will output S just so that we know that we got the bad output. Okay, so let's give that a whirl. So this is something you'll need for a lab very soon, by the way. So this is an idiom you need to be aware of. So let's just try this. So give it 10, that worked. Give it Fred, that didn't work so well. Actually, did I compile it? Yes. Okay, so let's do, so this is really bad. It printed out a lot of stuff and I can't seem to stop it. What should I do if I want to look at my output in this case? Because it quickly, I mean, gosh, lots of zeros. This isn't doing me any good. Put it into, use redirection and put it into a file. Now I'll be able to look at it. Okay? So let's change data. It's got mad and 30 in it. But my change doesn't seem to be working. So let's put it into output. Ah, that seemed to do okay. It printed 10. Now, let's just do it with data. Prints 10. And why was it prints 10 is out. Okay, so it works with mad okay. Now let's change data to be Fred. Ah, okay. Must have had something going, but it's still not exactly doing the right thing, right? It's printing 10, but then it's not getting in here and printing out that we have a bad value with Fred and then continuing on. Okay? So we're not exactly sure what's in play here. Okay, so we can try to, it's clearly, so what I would do in this situation is say, okay, am I even getting into the loop? Okay, I wanted to show you how you do debugging. So say, okay, let's see if we're even in the loop. So I'm say, I am in the loop. Okay, and we'll compile that and run it. 10 works, so I'm in the loop, and it prints 10. Mad. Okay, so what do we know? Well, in this case, it seems like it's returning false now. We're never getting into the loop a second time. It didn't succeed, and we're out. Okay? This is actually the behavior I more or less did expect earlier. Okay? So, looks like we're not even getting into the loop. Well, there's a solution to this. While true, we're going to turn it into an infinite loop. Okay? Now we have to do our read. And what I'm going to do is, I could do it this way. Okay? But it's a little redundant. What I'm really going to do is say, if cin into value, I print it out, else call cin.clear, print the value s, and everything should be okay. Okay? So let's see if that's going to work. Leave my debugging statement in. I'm in the loop. So let's enter 10. It printed it out. It went back to the top, and I'm back in the loop. Let's enter Fred. That worked. Bad input equals Fred. I'm in the loop. Let's enter 30. I'm in the loop. Looks nice. Let's get out. Oh no. Bad news, not getting out. Okay, what happened? Why, after I gave it the end of file character, am I not getting anywhere? In fact, I'm getting bad input equal Fred, bad input equal Fred, bad input equal Fred. What's going wrong?
True is always true.
It's always true. I reached the end of the file, so I get in here, the read fails, I clear cin, I tried to read my next input, but there's no input, so it fails again, leaving the previous contents of Fred in S, so it prints out bad input equals Fred, comes back up to the top, fails because we're at end of file, clears cin, tries another unsuccessful read. So my problem is that when the read fails, there's actually two cases. One is I may have reached EOF, and the other is that it might have been a bad value. So this is where I have to use EOF. So else, I know I have an error condition, but the question is which of two error conditions do I have? If it's EOF, I just want to return. Okay, that's going to get me out of here. Okay, Dr. Plank uses exit. Feel free to use exit if you want. It's actually a little more accurate to use return, and the notes explain why. Okay, so this is a little more complicated. So I have to check if the read fails as to whether I have an EOF condition or whether it simply failed due to the fact that I have bad input. Okay, so let's try this one. And Okay, enter 10, that's good. Enter Matt, that's good. Enter Brad, that's good. Enter 30, that's good. Enter Control D, perfect. Now, before we hand in the lab, what do? Get rid of what? Debugging statements. Bye-bye debugging statements. Okay, and there you have it. This, make sure you have it because this could be helpful to you in lab, where you will be reading bad input and having to recover from it. So this is a case where you have to use EOF because you're checking to see whether you have a bad value or whether you reach the end of the file. Okay, so in lab, I forget actually, I have to check whether it's this week or next week, but you start getting into situations where you have to deal with bad input and recover from it, and this is how you do it. Okay, so questions about this? We good? Okay.
How did you, what was the command to open what you got on the left side of the screen separate from your term?
This is a Mac thing. You mean how did I create two windows or?
Like how did you open Vim in a separate window?
What I did was actually on the Mac, I just went in terminal, there's under shell, I went to new window and got myself a new window.
Okay, so since I got a surface, I'm just out of luck.
Since you got what?
The surface, I'm just out of luck.
You're out of luck. So you'll just have to flip back and forth. Believe me, what I'm doing here is pretty uncommon. Usually you can't put them side by side. Usually you'd need two monitors to do it. The input is so tiny I was able to put them side by side. Yes?
How does the cn.eof work if you're putting things in through standard input normally instead of redirecting from a file?
So that's actually what I was doing here. I was, in this example, I was going directly.
You just control D.
Yeah, I just controlled D. So it works fine. Other questions? Okay, so I'm not going through everything in the online notes, but Dr. Plank is cute sometimes and likes his puns, so do read up on the reading single characters using CN. We're not going to deal a whole lot with single characters. The one thing, I'm just going to mention it briefly, with reading single characters. So if you have a char variable and you use CN, CN ignores white space. So if you think that you're going to read a white space character like a blank into a char using CN, you're sadly mistaken. Okay, CN only reads non-white space. So there are other ways that you can read single characters like using getChar, but we're not going to really care about that in this course. So just know that CN will not read white space. It always treats white space as a delimiter. Okay, so if you read single characters using CN, it only reads non-white space characters and skips over white space. Okay, so that was that thing. Because we don't really get into it, I don't care. Do read his 4 common CN errors. We already have gone over a couple of them. This one is really pernicious while not CN into N1. Okay, you're thinking that it's also checking for an error condition. Remember, we say if CN into, it worked, and if not, it doesn't. So this looks like it's saying if CN failed to read into N1, then do something. Okay, but if we run the program, which is, we're trying to read 10 integers here. It's saying for I equals 0, I less than 10. If it ever encounters a bad integer, it says done, and it returns 0. So he actually does it, and he has 10 good integers in his file, 10, 11, 12, 13. And when he executes his program, instead of printing out the integers, it always prints out something bad. Okay, and what went wrong, does anyone know what went wrong here? It should have read the integer properly, and it should have printed out the integer, but it didn't. Does anyone know why this didn't work properly? Then it's good we went over this.
Not should be outside the parentheses.
So the not should be outside the parentheses. The problem is there's two operators here. The exclamation mark, which is the not, and the greater than, which is the read operator. Okay, and all of you are implicitly assuming that C++ is treating the operation like, as if it's written like this. Okay, but that's not how it's treating the operation. It's treating the operation as though you wrote it like this. Okay, yeah, I see someone going, what? Well, it turns out that there's, remember precedence? So if you say 3 times, if you say 4 plus 3 times 6, does it evaluate as 42 or does it evaluate as 22? We'll take a vote. How many think it evaluates as 42? Raise your hand. Okay, and how many think it evaluates as 22? Okay, well, shouldn't the plus operator execute first? It was there first. No, which had the higher precedence? Times, right? Okay, it's the same thing here. There's two operators right here. Guess which one has the higher precedence? The not operator. So it gets applied first, so it says if not cin. Okay? Well, what that does is it's equivalent to saying if not cin.good. What it's asking is cin in a valid state? Why, it is in fact in a valid state. So this returns true and the whole expression evaluates to false. Okay, so not cin turns out to be a false statement. This looks funny. False greater than n1. In CS130, did they tell you that there was an alternative interpretation for greater than? No?
Yes.
Yes. What is the alternative explanation for greater than when it's applied to an integer? Bit shift. So now false gets converted to what? What integer does false get converted to? 0. So it tries to bit shift 0 to the right by n1 bits. Doesn't work out too well. So in fact, we get if 0, well that's false, so it simply prints out whatever used to be in n1 without ever performing the read. Because we managed to subvert the read operator into a bit shift operator. And C++ never even gave us a compiler error message because to it, this was all legitimate. Okay? But to you, you're sitting there with your head in your hands after an hour thinking, what the? It's right, but it's not. Okay, so the moral of this story is if you're going to do this, you got to put parentheses around the CN operation or else you'll be in a world of hurt. Okay? Questions?
Why does it always put in a 0 instead of like a null character?
For what?
Like if you send in a bad value, why does it always put 0 instead of a null character?
Oh, because an integer is the default. 0 is the default value for an integer. It would use an empty string, presumably, for a string. For a pointer, it would probably use null. So it reverts to whatever is the default value for that particular type. That's why. Float would probably also give you 0.0. I'm not sure what it would give you for a character. It'd probably give you literally 0, which is null. So, okay. So read that one. Okay. We went over the cn.eof is not proactive. That was the big point about the last line being printed twice. I don't see this error a whole lot, but just remember, CN reads a single word. It doesn't read lines. So as soon as it reaches white space, that's where it ends. And when you clear CN, remember that it's not enough to just clear CN. You also have to remove the bad value from the input stream. And you have to do it in that order. Okay? Okay. So, moving on. Are we good with input? Okay. Let's move on to output. So, again, you read, most of what you read should have been pretty much review. So, the book told you about cout, and it brushed you up on all the formatting conventions of cout, which, let's face it, are a pain in the neck, okay? If you want to format something so that it is, a second, so actually do this for a second, take a moment, and you have an integer, no, you have a double. See if you can write the set of formatting commands that will print out X in a field, let's see, make it left justified, X left justified, in a field 10 characters wide with 2 digits of precision. Okay? I'm going to give you 2 minutes to do it. You may or may not be able to remember how to do it using cout, but see if using the IO manipulators you can figure out how to print out X left justified in a field 10 characters wide using 2 digits of precision. So for example, if it's 8.99210, you want 8.99. While you're all doing that, does someone have that sign-up sheet? Way in the back, thank you. Wow, look at y'all. I'm impressed. Thank you. Someone had a pencil. This is not my pencil. Someone's out of pencil. Okay, so we ready? Cout. To do this, we say cout left. Then, how do we make it 10 characters wide? Set W 10. Then how do we print it with 2 digits of precision? Set precision. We don't need show point actually in this case. Do we need anything else before we do the X? Fixed. Very good. If we don't say fixed, then it would actually only print out the first 2 digits. Whereas once we say fixed, it prints out 2 digits after the decimal point. Okay, so that's kind of verbose, wouldn't you say? I would. I find it annoying to have to write all that. So there is another print command called PrintF, which comes from the C world rather than the C++ world. And it allows you to print formatted output, hence PrintF, but it allows you to do it more succinctly. Okay, now, first thing, if you're going to use PrintF, remember to include C standard I/O because it's not in the I/O stream library. It is in the C standard I/O library. So if you're going to use PrintF, you need to include C standard I/O. Okay, so if you just want to print a string using PrintF, PrintF is a function. So you just give it the string to print. Hi, Brad. And there's no endl anymore, so if you want a new line, you got to end it with the new line character. So that prints the string hi, Brad. Okay, but you're thinking, well, actually that's not what you were advertising, Dr. Van der Zanden. You said that I could use PrintF to print out variables formatted in a little more succinct way. So let's see how we would print out that X using PrintF using the same thing. So I'm going to write it and then I'll explain it. Okay, this is the same command and it will actually print X in a field 10 characters wide, left justified, with 2 digits of precision. Okay? So you might want to write that down and then I'll tell you what's going on. Okay, here's what's going on. The minus sign says to left justify the output. If you don't, then by default, remember that output is right justified. Even strings by default are right justified. So the minus sign says to left justify it. You're probably pretty confident about what the 10 does. That's the field width. So print it in a field 10 characters wide. You're probably also pretty comfortable that the .2 is saying 2 digits of precision. And the F tells it that this is a floating point number. The \n is just saying to print a new line character. Yes.
Don't you have to have a percentage sign?
Yes, thank you. That's right. Sorry. You need to put a percentage sign in front of it. Thank you so much. So start it with a percentage sign. So the percentage sign says this is the start. The percent sign says start of a formatting directive. Because otherwise, it's just going to think that it's supposed to print it out literally as a string. So the percent sign before it says this is a formatting directive, and the F ends it. Okay? The only big drawback associated with PrintF is that you have to tell PrintF the type of the value you're printing. Cout always figures it out for you. The big advantage of cout is that it automatically figures out the value of the variable it is printing, and it prints it for you. PrintF is dumb. It cannot automatically figure out the type of the value. So you have to tell it the type of the value. So when you're printing a double, it's F. Okay? If I was printing an integer, so the types are, if you're printing an integer, either %d or %i tells it it's an integer. %f equals a double. Please don't use floats, use doubles. Floats don't have as much precision. %s indicates you're printing a string. %c indicates you're printing a char. Those are the big four that you need to print. And then you can print stuff in front of it. So if you say %10s, you're printing a string 10 characters wide. If you're, say, %-10s, you are doing what? Left justifying the string in a field 10 characters wide. Okay. If you say %6.2d, what do you think happens? Don't do it. Integers don't have decimal points. Okay, so while you can indicate that an integer can be in a field of some width, integers don't have decimal points, so don't try it. I actually don't know what happens if you say 6.2d because I never do it. Okay, so those are the big things with PrintF is you can it starts with a format directive starts with the %sign. Then if you want to left justify, it's minus. If you want right justification, you don't need to put anything. The field specifier with specifier is optional, but it comes next, as is the precision. It also comes next. If I just want it to print the floating point number with 2 points of precision, but I didn't care about the field width, I just say %.2f. So now it will print it in a field just wide enough to accommodate it. The period is part of the field. So if you say 6.2 and your value is 3.25, that's actually 1, 2, 3, 4 characters there. Okay. Remember, it doesn't truncate. So if you say %6d and your integer happens to be 70,305,602, it won't truncate it. It will print the full value. So the width thing is a minimum, not a maximum. Okay, so it doesn't truncate. If the value is too big to fit in the field, it will print completely. Okay, if you want to print out multiple things, that's easy. So let's say I wanted to print out x and y. I could say, for example, printf x equals %3d, maybe a space y equals %5d \n. and then x comma y. So the first argument to printf is what is called a formatting string. And the remaining arguments are the variables to be printed. Okay? So, formatting string, and then your second through 10th things are the variables to be printed. So here, x equals is literally printed out. It's not part of the format directive. Then the percent sign starts a formatting directive, so that matches x. And then it prints out whatever is in x⁵. If x is, say, 1, it will pad it with 2 spaces. Then there is a blank space here that it prints out. It prints out y equals, and then it prints out the value of y in a field 5 characters wide. So if y is 103, it prints out 103 plus 2 leading characters of spaces. So that's printf. You'll have to use it in a couple labs. We will tell you specifically in the lab when we want you to use printf, and you can use either cout or printf when we make it optional. Okay? So at any rate, I will see you Thursday. Remember, 9:55 on Thursday. We'll start